me encantaría hablar un poco más.
Disagree whose payloads are on it. Now, this is a Black Brant IX rocket. So this is the thing that's going to be launching later tonight. We will actually go up close and personal, so to speak, with this rocket later this evening with a pre-visit we had last night. This is the magic of television. Now, on this rocket, there is one experiment. It's called the X-ray quantum calorimeter. Now, this is run by Dan McCannon and the team at the University of Wisconsin. And so this mission is critical, and we'll talk a little bit about its purpose to understanding the X-ray light in our galaxy, how it operates. And this is part of a bigger story about why the Arnhem Space Center is here, and that is to see the southern skies. Now, we will have others. Yep. So we're just getting those checks. We've actually just heard that airspace is clear. We're getting an update on the countdown. We are still at that half-hour delay time. So we will be panning to these cameras as we go. Now, the beautiful thing about the Arnhem Space Center is this is an Australian endeavor. And we're going to go now and hear from Ben, the operations manager of the site.
My name's Scott Bissett. I'm the Deputy Chief for the NASA Sounding Rockets Program Office, as well as the Australia 2022 Campaign Manager.
Bueno, tenemos el audio duplicado. Mi voz va mejorando de a poco, ¿verdad? Luego voy a actualizarles un poquito cómo está mi situación de salud. Pero ahora me voy a mantener en el chat para minimizarle mi esfuerzo, ¿ok? Les agradezco enormemente que siguen en el canal, que me siguen apoyando. Gracias.
Muy buenos días. La NASA lanzará 3 cohetes de sondeo suborbitales en junio y julio de 2022 desde el Centro Espacial Arnhem en el territorio del norte de Australia para realizar estudios de astrofísica que solo se pueden realizar desde el hemisferio sur. Las 3 misiones se centrarán en Centauri A y B, 2 del sistema de 3 estrellas Centauri, que son las estrellas más cercanas a nuestro Sol, y los rayos X que emanan del medio interestelar, nubes de gases y partículas entre las estrellas.
It's great to think that you're going to make that a family business.
Yeah, we get into work, yeah.
Yeah, that's right.
Yeah.
Well, thanks for joining us, and you got a busy night tonight.
Yeah.
And good luck.
Yeah, thank you very much. Pleasure.
So during this program, as we're live now, you'll see a bunch of these pre-recorded content that we
Las 3 misiones nocturnas de cohetes de sondeo se lanzarán en cohetes de sondeo Black Brant IX de 2 etapas, desde el Arnhem Space Center, que es propiedad y está operado por Equatorial Launch Australia o ELA.
We're still scheduled for launch at about 11:14 Australian Central Standard Time. The person on the site right next to me, Daryl, he is the man making sure all the checks are happening, all the timing is in sequence, and everyone's doing their job, including me. And for those of you who had some audio issues as we were swapping to it, sometimes if you hit refresh on the stream, hopefully that should be fixed. Now, this rocket is a 22-meter rocket that's carrying about a 2-ton total. All the timing is in sequence and everyone's doing their... We're still scheduled for launch at about 11:14 Australian Central Standard Time. The person on the site stream, hopefully that should be 2-meter rocket. That this rocket is a 22-meter rocket that's carrying about a 2-ton total carry payload, and this includes the primary mission, which is a X-ray quantum calorimeter. So this is
And tonight, we're doing Australia's first space launch from here in Arnhem Land. So watch this coverage and you will see the first commercial rocket launched into space from Australia and the first time that NASA has ever launched from a commercial spaceport ever.
El Centro Espacial de Arnhem es una instalación de lanzamiento espacial comercial ubicada en la meseta de Dupuna cerca de Nhulunbuy. Las misiones de la NASA serán los primeros lanzamientos desde Arnhem.
So the excitement level is increasing a bit. So that's good because I want to enjoy it.
Yeah, I was going to say, that's the thing, right? I mean, because this process has been not just the past few weeks or past few months. This process has been quite literally years in the making.
This has been an exercise of 7,000 cuts. We submitted the start of our launch license about almost 2 years ago to the day.
Yep.
That's been a long, arduous process. The building of the site here and doing anything in a remote location is challenging. And of course, if you're going to be in an industry sector, let's pick one that's really sort of nice and simple like space. Okay?
Yeah, exactly. It doesn't need any sort of technology
No,
involved.
no, that's right. And you don't need to find people who know anything.
Exactly.
Right? So we've had some challenges and it's been a long road, but...
Daniel está preparando un video para contarles sobre su salud. Esta tarde será subido al canal.
And I think there's just a buzz that you're starting to see amongst, as I said, not just you, but everyone who seems to be working here. You know, there are people who have been, you're talking to someone who's been working here on site for the past, 12 weeks. He's like, I just want to see the launch tonight, right? I just want to get to that moment.
Yeah, I don't think we did it on purpose, but I think what you do is you leverage what the end game is all the way through these things. So everybody starts to get a feel for, I want to get to the end and I want to see, what this is all about. And what's a really interesting dynamic is the mix of, the 75 years of experience of NASA and all the people who are just insanely professional. They're so good at what they do.
I mean, and they're so regimented and, rehearsed.
Some could say inflexible, but let's just say they're very structured in what they do.
Yeah.
And then on the other side of it, it's us. We're here, we're sponges. We're trying to soak up every bit that we can from them, and you could not want, as a startup company, to have a better launch customer, pardon the pun. It's pretty hard to do these conversations without working in this space and the launch customer. But anyway,
that's the beauty of the job, right? Is the puns.
So we You know, we couldn't have a better customer to start off with because of both reputation, skill, and just their generosity of passing on information and working with us. And at the end of the day, you know, there's this one guy who has to finally decide, are we going to launch it?
Yeah.
That guy looks like me. So, so I have to remind them of that occasionally.
And it's also not the responsibility just of the people on the site or NASA or the science payloads. It's, you know, in some degree, the entire community, as you know, we've talked about, who's been invested in this.
Huge span of stakeholders from, you know, the Northern Territory government have been really instrumental in getting us off the ground, all the way through to all the different traditional owner and Indigenous groups who we want to engage with, but we have to engage with because we're on their land.
Yeah.
And specifically for these 3 missions, the payloads are landing back on their land, so we have to coordinate with them. And there's then the absolute myriad of interagency things that you need to do, from explosive ordnance, environment, transport, aviation, maritime.
Because you have people around CASA, the space agency, safety, site rangers. You know, it's not just rockets. You know, this is going to be the first commercial launch in Australia. And that means a lot for the Australian space industry, not just ELA.
Yeah. As I've travelled around the globe in the last sort of 12 months, talking to all the major players in the space world, one of the things that has really struck me is there are Australians everywhere.
Yep.
And so, to some degree, bringing that home and showing that we have a capability here,
right.
and this is our coming out party in a big way, and to show that Australian technology and innovation and entrepreneurship can, you know, be at the forefront of the world stage in space is a big state. And I think that there are a lot of other great Australian companies in space.
There is.
But, you know, the Fleet Technologies who are doing satellites, the Skycraft in Canberra doing satellites.
Who will hopefully have another launch this year.
Yeah,
that's right.
and Myota. You know, Southern Launch, our launch partners, who are coming up tonight, which is really nice.
That's right, and hoping to have that, you know, this kind of same facility, but in the south. And that's the beauty of it, is this isn't just representing this site, it is what Australia is going to become.
But certainly with Southern Space, we talk to it, Southern Launch, sorry, we talk to them all the time. We get on really well with them because we have common problems, you know, and common challenges. So we try to help each other out where we can, and I'm a big believer in, you know, the sum of the parts is always going to be, you know, the best part of it.
And so, you know, let's 10 years. We have a first launch tonight.
Yep.
What do you think Arnhem Space Center looks like in 10 years?
Well, where we're standing at the moment is on what I would call, you know, Site 1.
Yep.
Yeah, the end of the first phase, which gives us the ability to do medium-sized rockets.
Yep.
So up to about 450 to 500 kilos in payload.
Yep.
The rocket itself sitting on the pad can be up to, you know, 200,000 kilos sitting on the, so reasonably large. This is Site 1.
Yeah.
Immediately, you know, a kilometre, you know, to our east here is Site 2, and we will eventually have, you know, the drawing at the moment has 24 pads on it.
Yep.
It has to be very carefully planned so that we can do a launch effectively every 6 to 9 days.
Yep. And so tonight, it's all happening tonight, right?
Yep. We're now inside the countdown. We started the countdown at 8 hours before launch.
Yep.
There's a whole bunch of activities. It's incredibly detailed and scripted what happens, the number of checks, the number of players. There's over 100 people on site. All extraneous, non-required people are off-site for safety, but they're working through the checks. They're rehearsing, you know, as they go and then executing. We have to have a huge amount of external communications as well. So airspace, maritime, local emergency services, coordinating with security, just talking to everybody else on site as to
Because it's still a rocket that is being launched tonight, right? That's the thing.
Absolutely. You know, we're about to fire a projectile that's going 300 kilometres into space.
Yeah.
And then it's coming back to exactly where we want it.
Now, so
Attention all stations, attention all stations, attention all stations. The launch countdown is now at T-minus 60 minutes. Facility managers out.
And so we've just gotten the official call. We're now at T minus 60 minutes to the first launch. So now we will resume our countdown for an hour till then. So that puts still the launch right now on our new target of 11:14 Australian Central Standard Time, 11:44 Australian Eastern Standard Time for this rocket, 1:44 UTC. Now, we will be here until this thing takes off because that's what we're all here for. We have people gathered from a number of agencies to make this happen. And again, we will keep cutting to live vision of it. When the rocket takes off, again, as a scheduled time now, and just under an hour from now, we will be showing you shots from the launch pad as it's ready to take off. And we're going to follow it for as long as it goes. Now, this is a sounding rocket. So the sounding rocket is what we call a suborbital rocket. So it doesn't quite reach.
Buenos días para los que recién se suman. Estamos esperando el lanzamiento de un cohete Black Brant IX, del tipo suborbital, desde Australia. Anunciaron una demora de 1 hora 0144 UTC sobre la salud de Daniel. Él está preparando un video para contarles sobre su salud. Esta tarde será subido al canal.
The thing about that is that's just the minimum height really you say to reach space. This rocket tonight is going to reach a height, what we call apogee, of 350 kilometers. Now this is necessary for the science payload. Again, this is a X-ray quantum calorimeter, so this is measuring the Milky Way emission. So if you go on a dark sky place like we are here in Arnhem Space Center, you can see the beautiful Milky Way going across the sky. Now, the Milky Way can be seen in the southern and the northern hemisphere, but you actually get to see different parts of the Milky Way. One of the unique things about the southern skies is you actually get to see the galactic center. This is the heart of our Milky Way galaxy. This can be only viewed from the southern skies. You cannot view from the northern skies. So this is kind of one of the amazing things that we get to see. Now, as I said before, we did have a slight launch delay. I am just hearing the rain yet again. So much for the Darwin Northern Territory dry season as the storm is pouring above us. Now, the great thing about live TV is we're going to keep going, and you're going to keep watching until we see this rocket take off. Now, the weather doesn't necessarily impact it as much as you may think. One of the big things the rocket does need to have is the wind coming down. You do need the wind to have a fairly stable, and it's not just the breeze, it's really the gusts. They cannot have a lot of gusts with it. So the rain isn't as big of a deal as actually one may think. Things like the science instruments are all contained inside the rocket, obviously, so they're protected from those environmental variables. So what you're really worried about is any extra wind, any extra storms that may happen to the gantry. That's that metal thing that we were just looking at that hopefully we'll cut to in a second to see what the rocket is up close. That is the support structure for the rocket before it takes off. Now, again, the wind is the key here. So far, the winds seem to be actually cooperating. So even though we're getting these refreshing Northern Territory dry season showers, which is fairly uncommon from up here, it is the sort of thing that you just deal with when you're launching it. You know, we often hear of launches from Florida. You know, Florida is Cape Canaveral's kind of in a swamp. You know, they have gators, we have crocodiles. So it's kind of a similar idea, but we are not going to be as impacted as much maybe as what you would get in Florida because, again, the rain's already stopped. We're actually already still in countdown of the rocket. So not really that necessarily big of an impact as one may think. Just create some fun experiments for all the people working on site. And, you know, speaking of on site, this launch is the first commercial mission for NASA. Yes, NASA works with lots of private companies. They work with SpaceX, Blue Origin, Boeing, Airbus. But one of the things that is quite different is when NASA's usually launching a rocket, they are operating the spaceport, or at least have a fairly big setup in it. This mission is done completely with a private company, Equatorial Launch Australia. And so this is the very first commercial launch that NASA is doing, where essentially NASA is controlling the rocket about 150 meters behind me, But here it is the Australian staff of Equatorial Launch Australia that is managing that process. They are the ones responsible before launch, during launch, and what happens after launch. And what happens after launch is the critical recovery of the rocket components and the science components. And so we're actually going to go start hearing from NASA, pre-recorded obviously. They're a bit busy getting this rocket ready. And from the operations manager, Scott, who he's in kind of charge of the 3 missions that are happening in Australia right now. And we're going to hear about his experience, what it's been like to work on this very historic mission. Again, not just for Australia, but NASA as well.
Bissett. I'm the Deputy Chief for the NASA Sounding Rockets Program Office, as well as the Australia 2022 Campaign Manager. We're really excited to be here. It's been, over 10 years in the making to get out here. It's been over 20 years since we've actually launched from Australia. I've personally been working on this for 5 years, so I know myself, the team, the science community back home are really excited to be back here and be doing some really great and critical science for NASA. So it's the first launch for NASA from a foreign commercial launch site. So we've probably been working at this for over 10 years. I've personally been working at it for 5 years. 2 to 3 years that was actually just the legal, getting NASA legal to buy in on doing this commercial. And then the rest just planning. When I came out here in 2019, this was all trees. The first time we did the site survey, so a lot of work and just getting everything set up.
And so how did you guys decide for these 3 launches launching from here?
Sure. So, we had in the past, back in 1995, we were able to launch from Woomera.
Yep.
And we intended to go back there, but because of some legislation, it made it very hard for NASA to get back there. It was more geared towards commercial and DoD. And so after several years of trying to work that angle, commercial launch, started to become big here, and we heard about Equatorial Launch Australia. And for these 3 missions, we're looking at Southern Hemisphere targets. And they're very expensive telescopes that we'd like to get back.
Yes.
So having a land-based range with a lot of wide open area where we can bring these payloads back down on a parachute was critical.
Yeah,
so
landing in the ocean is not conducive to recovery of these things. Yes.
Electronics. It can be done, but it's a lot more risky.
And it's a lot easier when you have a lot of more land that you can recover and safely navigate, right? Because that's one of the critical aspects here is when it takes off, there's not a lot downrange, so to speak.
That's correct, yeah. A large, wide open swath of land where we can actually land these things and go pick them up.
And so when you're actually deciding and doing this launch, what does it look like? Because I think everyone thinks T-9, 8, 7, 6, but the day starts long before then, right?
That's correct. So for the first launch, we actually start at 8 hours and 15 minutes before the T0 time with a lot of actually work on the experiment itself. So this one is super cooled, so we have to do some liquid helium transfers. So there's about 3 hours of experiment prep before we actually get into the countdown itself. And then the way we do the countdown, we do what we call a horizontal check, where the payload's still sitting in a horizontal position, and we run through our 10-minute terminal count in that horizontal position to make sure all of our systems are working as expected all the way through T0. If that looks good, then we actually go out to the pad and we'll do our arming. So we actually arm the payload, connect up our firing lines, pull the shelter back, and then we will elevate to a vertical position. We then again run through that 10-minute count and make sure everything's working. No cables will come loose during the elevation. Once that's all good to go, then we're ready for our terminal count. So our terminal count's only about 10 minutes long.
Okay, so it's still
it's a long period of time.
I imagine it's also a long period. I also imagine it's a long 10 minutes, right? It's not just sitting there twiddling your thumb. There's a bit to do.
There is. So in that 10 minutes, we start by powering on the payload itself, and then there's a lot of checks. We bring systems on one at a time, make sure we're getting good data, and then about T-3 minutes, we actually switch everything to internal power. So we're getting housekeeping data back, say, okay, our battery levels are good, everything's on internal power, and then, at about 90 seconds out, we get the final go call from the team, and we're hopefully green when we hit that point.
Now, how long does it actually take from that go point, launching, to actually reaching not its orbit, but its peak height?
So it's less than 10 minutes. I can't recall exactly what it is for the first one, but the entire flight from launch until the payload comes back down on chute is only about 15 minutes.
Yep.
And of those 15 minutes, we're only taking science data for about 5 minutes.
But that's a critical 5 minutes for a lot of these experiments, right?
Extremely critical. So everything has to go as planned. We do a lot of rehearsing for those 5 minutes. For the second two missions, they actually have what we call an uplink. So they'll be getting video feeds back on the ground real time to make sure they're pointing on target.
Yes.
And if we see we're offset by some amount, they actually have a joystick more or less, and they can control to point us back on target. So we rehearse that a lot leading up to, because the last thing you want to do is get up there, you have 5 minutes to get on target, and you gotta swing left and shoot it on right,
and then you miss your target
and then you
completely.
Miss your target, and that's
it.
a technical failure, unfortunately.
Yes.
But,
and so how often do you actually are launching sounding rockets? Obviously, first time for a long time in Australia, but for the U.S.
So in the U.S., our program travels around the world. So we do launch from Wallops, which is NASA's only owned and operated launch range. But we also launch out of Norway, out of Svalbard, Poker Flats, Alaska, White Sands, New Mexico, the Marshall Islands, and now Australia. But our program's sort of built around 18 to 22 missions a year.
Okay.
In fact, we actually launched a mission from Wallops this morning at 5:30 in the morning for a student mission back home.
Okay, and then you're getting ready for...
Less than 48 hours later, hopefully we'll have one launched from Australia.
And so is there a view that by having multiple sites...
La NASA lanzará 3 cohetes de sondeo suborbitales desde el Centro Espacial Arnhem, en el territorio del norte de Australia, para realizar estudios de astrofísica que solo se pueden realizar desde el hemisferio sur.
Wherever the grants come in, we're happy to go. But there is a lot of interest. It's been, like I said, over 2 decades since we launched in the southern hemisphere. So there's quite a backlog of science to be done down here.
And that's the critical thing, right? All of these experiments require targets in the southern skies that you just can't do from a northern launch site.
Correct. There's just no way to do it. So you physically have to be down here. And like I said, Australia is one of the only places you can get.
Las 3 misiones se centrarán en Centauri A y B, 2 del sistema de 3 estrellas Alpha Centauri, que son las estrellas más cercanas a nuestro Sol, y los rayos X, que emanan del medio interestelar, nubes de gases y partículas entre las estrellas.
I know there's several scientists that would have loved to come with us on this mission, but we sort of limited it to 3. But assuming this one's successful, our goal is to come back at least every 3 to 5 years, and then once you prove it can be done and it gets easier to come back, then it's easier to do it more frequently than every 3 to 5 years or 20 years.
I guess the first time driving a car is hard. The 30th time you've done it, it's just kind of commonplace. That's right.
And that's how we started at some of our other remote ranges, where it was every 3 to 5 years, such as Norway, and now we launch there nearly every year.
Well, look, thanks for joining us, and we will look forward to catching you in action later.
Fantastic. Thank you very much.
Thanks. Now, we are approaching that kind of critical time of having the rocket take off. So we're just under almost 47 minutes to launch. Now, there hasn't been any changes to the schedule aside from that initial 30-minute launch. So we're still just 47 minutes now, just ticking over that mark to launch. Now, one of the things, as I said, that we have happened up here at the Arnhem Space Center is we've had a bit of rain during the dry season. So now, when we go to this live shot of the rocket, you may see a few raindrops on the camera itself. So fortunately, that distortion is from the rain. Now, one of the good things about a rocket is it'll kind of dry the rain later, so we're not that worried about it. But it has been drying throughout the day, so it shouldn't be as big of a deal. Now, what we are looking at here is, if you could just see just on the right is the rocket itself. On the left is the gantry. This is the support structure for the rocket to take off. Later in the program, we have gone up close to the rocket during the daytime, obviously, so we can see it. Now, again, this is a night launch in Australia. A lot of people wondering, why is it a night launch? Now, there's a few good logistical reasons why. There are operational considerations happening for both the launch and the coming down of the launch. It also is an astronomy mission. You kind of want it to be dark at some point when you're doing some astronomy and calibrations. This also is being coordinated with NASA Wallops facility. Now, NASA Wallops is in the east coast of the US, and with the time difference, this is actually kind of convenient, believe it or not. It's better than being completely in the middle of the night. And we also have a 3-hour launch window. So if there is further delays, we still can go up to 3 hours post our initial scheduled launch. Again, that is not that case as of now.
Mañana tendremos un lanzamiento histórico e increíble. Un pequeño cohete electrón pondrá en órbita una nave del tamaño de un horno de microondas doméstico alrededor de la Luna. Servirá para validar la órbita casi rectilínea de Halo para la futura Estación Espacial Lunar Gateway.
And I think you are too if you're joining in to see this. And so when we see this rocket taking off later, we will see the shot from the ground as it takes off, and we will panning again as far and high as you can see. Now, as we mentioned in the beginning of the show, only if you're in the vast regular region, so to speak, of East Arnhem and Arnhem Land will you actually maybe be able to see anything. You're not encouraged to come here. Now, this is not because we like people. This is purely for safety and operational reasons. You're more than welcome to look at home if you're in the region. Now, if you're in Darwin, you're going to be too far west. Queensland is too far east to see this. So unfortunately, you will not see it. But if you're in a southwest trajectory from Nhulunbuy, up here in Yolan country, you may be able to see it as it takes off. But then again, you can also watch it here on our stream. Now, one of the exciting things about this is why NASA is here. And this is, I think, a critical part of this story. Why did NASA choose the Arnhem Space Center? Why did NASA say, now's the time to come and launch a rocket from Australia? Well, there's some really good reasons. As we're about to hear from Kevin, one of the science investigators, one of the people who's been pushing NASA for over a decade to come and do this, is to actually be able to do the science that is only visible in the southern skies. Now, our Earth is a globe. There are some things you can see from the northern hemisphere, some things you can see from the south. And yes, the southern hemisphere does have better skies than the northern hemisphere. We also have less light pollution. We are in a beautiful dark spot where the stars just pop out in the night sky. And some of these targets that we'll be looking at, like this first instrument looking at the southern part of our Milky Way galaxy, like the second and third flights that will happen on 4 July and 12 July, they need to specifically look at objects that are only visible in the southern hemisphere. You cannot see it from the north. And the beauty of being at the Arnhem Space Center is with the remote location, with the ability to control it, and being so close to the equator, this is a great combination for launching a rocket. And that is, again, why we are here today. This is why NASA is here to have this. And so we're going to hear from Kevin France. He has been one of these people pushing NASA to come here to have this launch. And he has as much invested, if not more than it. He has 2 experiments involved, the 4th of July, which is the second launch, and the 12th of July, which will be the third launch. He wants to see this happen because he wants his precious data and he wants his science. As something I can appreciate. So let's go hear from Kevin, who we caught up with earlier today.
Hi, I'm Kevin France from the University of Colorado. I'm NASA's campaign scientist for the ELA launches. I'm also the principal investigator of the Sistine mission, which is going to launch on July 4th. I've been working on this project for about 10 years, trying to find a way to bring our telescopes to the southern hemisphere to observe Alpha Centauri. I'm just extremely excited to be here at this beautiful new launch site, be able to launch on the 4th and see this exciting ultraviolet data of Alpha Centauri A and B.
Kevin is the campaign scientist, right?
That's right.
And the second mission, though, is a tad closer to your heart?
That's right, yeah. I'm also the principal investigator for the second mission, the Sistine flight that's going to go on July 4th.
Now, what is Sistine going to do?
So Sistine is an ultraviolet spectrograph that's going to study Alpha Centauri, very beautiful southern hemisphere sky, bright star. And we're going to study the ultraviolet radiation from that star to understand how habitable planets may exist around that star.
So yeah, so Alpha Centauri is that star near the Southern Cross that
That's right.
we love to look at. And so how many planets do we know of around Alpha Centauri?
So there's a debatable planet around Alpha Centauri today, but it's a huge target for finding and searching for Earth-like planets around solar-like stars. So Alpha Centauri is actually a spectacular twin of the sun. And so being the nearest sun-like star, it's the focus of a lot of our efforts to find Earth-like planets.
Yeah, because it is that, and that rough idea that maybe one day missions could be sent even to Alpha Centauri in a very distant future, at least.
Right.
But it's the closest we get, really.
That's right.
Besides our sun.
That's right. It's our best shot to find another, Earth 2.0.
So when you say ultraviolet, so what do people mean? So in Australia, we're very used to being sunburnt during the summer. So is this the sort of same ultraviolet light that you're looking at?
It's actually even more ultraviolet. It's all part of the larger electromagnetic spectrum, but the rays that we're worried about at the beach are, we call them in wavelengths 300 nanometers.
Yep.
We're about 3 times shorter wavelengths than that, down to about 100 nanometers.
And so that means you're also probing hotter bits of the star in the system.
That's right. It's also why we have to put it on a rocket, because we have to get above Earth's atmosphere, which is the protective layer is great for us when we're at the beach, but rough if you're trying to study the light.
So that's the only way, right? So you have to put this on a rocket up there to see it, and because the target is in the southern hemisphere, you need to launch
from the south.
From the south.
That's right. That's why we've been asking NASA to do this for 10 years, because there are these beautiful targets in the southern hemisphere we just can't observe from our normal launch sites.
Now, you have a little bit to do also with the third mission, part of your broader team?
That's right. So the third mission is also coming from the University of Colorado, and I developed the science case for that mission as well. It's all part of our larger team that works together, and it's observing even farther ultraviolet light, what we call extreme ultraviolet light, which goes down to about 55 nanometers, which is really short wavelengths, yeah.
And is it also going to be looking at Alpha Centauri as well?
That's right. It's studying Alpha Cent 2. The idea was that the Sistine and the Deuce missions, Launch 2 and Launch 3, would be like a joint science project.
Okay,
and they would just cover different parts of the spectrum, because we don't have one instrument that can do everything.
That's right, because the technologies actually has to be very different from looking in those.
That's right.
So were these missions or telescopes built specifically for this, or have been flown previously?
So Sistine was developed, Launch 2 was developed for this exact science case. In fact, it was designed for this star about 7 or 8 years ago. The other mission, Launch 3 Deuce, it was also designed to study very massive stars. Very bright blue stars. And it's launched 3 times already to study blue stars, but we kind of tweaked it a little bit and repurposed it for this science case.
Now, what are you hoping the data will show? Because I think this is one of the exciting things is I think people think, hey, telescope goes up and you have pretty pictures on your computer screen. Not exactly what happens.
This is the less beautiful side of astronomy. This is spectroscopy, and so this is basically we take a spectrum of the star's light and we analyze where the bumps and wiggles in this wiggly line. But there's so much information there, because from a spectrum we can understand how hot something is, what it's made of, what its motions of the gas are.
Some of its age.
Its age, exactly. All these things we can't get from a picture alone. So, so we're building these into kind of a catalog of these ultraviolet spectra that we're going to use to understand which are the best star-planet systems to search for life.
And so how long does it actually take to get that data back?
It happens in real time. It comes down on the telemetry link that's on board the rocket. So we see it in real time. In fact, we use the real time video to decide how to point the rocket during the flight.
Yes, so Scott was talking about this, that you slightly have to adjust the rocket to align on the target, and so that's how you kind of know where to align?
It's like the world's most expensive video game. And we have our students. This is always a historical way that we do things in the project, is that we put the student right in the deep end, and they're the ones that are actually seeing the real-time display and are driving the rocket in real time to make the observation.
So they either get their PhD or they don't.
That's right. Or there's a tremendous amount of international resources wasted.
So when you're doing this adjustment, once the rocket is launched and you're essentially starting to get into suborbital space, you guys then take over all of that pointing and stuff like that,
That's right. It happens at about 100 seconds after launch. The attitude control system, so we go up with the pointy end up, and then our telescope looks out the back. So it flips over during the flight. There's a door that opens and our telescope points towards the target, and then we can start steering in to bring the target into the aperture.
And then do you have any control of it coming back down, or essentially it gets there, you're done, and...
So all we can do is control the pointing during the flight. We can also turn on and off the instrument if something were wrong, but we've knock on wood, we've never had to do that.
It'll be fine this time, don't worry.
But the rest of it all happens on timers. So at about 450 seconds after the observations start, the power will turn off, the door will close, and the whole payload starts to spin as it re-enters the atmosphere, and it spins to distribute the heat so it doesn't melt part of the rocket as it comes in.
So on the long side of the rocket, essentially, right?
That's right, yeah.
And so then you go out then the day after and recover your instrument?
That's right. So there's a helicopter that's on site, and we pick up everything for this launch. We pick up, it's a 2-stage motor, so we pick up the booster motor and the sustainer motor. And we also but we go first to go get the science payload, because it has the most it doesn't like to be sitting outside for a while.
Yeah, because it has to be very cooled, and it is a telescope, and a telescope that just got dropped back to Earth.
Exactly. So we go out the next morning, and we'll probably do a couple of flyovers to go find it, and then we'll land. I believe we're going to sling it up underneath the helicopter and ferry it back here, and then we'll test it again to see if it survived. And
Yes, so do you test? You do have
we
to
will.
test it when you come back.
We'll test it when we come back before we box it up.
And then do you do, depending on that status, do you do any slight adjustments or fixing, or kind of depends?
Not at this point. This is
Yeah.
really just an aliveness test for when it comes
Yeah,
back,
okay,
because
okay.
NASA wants to know if things survived and
okay.
the status of the instrument when we bring it back.
Okay, and then any other work that may be needed would happen back in the lab
It
in the
happens
US.
back in the lab. That's right.
Great.
Yeah.
Well, look, so the second launch is scheduled for the 4th of July?
4th of July.
And then the third launch is the 12th of July,
That's
correct?
right. Yep.
And those windows there's still a few launch windows for each of those?
That's right. I think each has 3 days
Okay.
that we can do. I think the conditions here have been really very nice, I
Yeah.
say now. So I'm pretty optimistic that we'll be able to launch on the original dates planned. But yeah, we've got a 3-day backup in case.
Well, look, it's great to have, and we look forward to seeing Sistine induce in orbit looking at Alpha Centauri.
Absolutely.
Anunciaron los próximos 2 lanzamientos para 4 de julio y 12 de julio, de esta misión con el Black Brant IX de Australia.
That
Part of the larger
2 experiments involved. So we're outside mission control. This is the just the rocket firing, but the rocket taking off and seeing the gloriousness of a rocket going into space. So we will have multiple cameras, we will have multiple action shots as we get closer to that time. So for those who missed the beginning, now you're probably waiting for a rocket to take off in about 2 minutes. We had an initial 30-minute delay added at the beginning, right at the beginning as we went live. Now, these delays are normal. I mean, delays happen all the time. The Space Launch System, for instance, this is NASA's new moon rocket. They were trying to test just the filling up part. This wasn't actually the launch part. This was what they call the wet rehearsal. Now, that was delayed multiple times, actually delayed 3 times, fully plus time during the day. So, these delays are normal. And again, part of the reason why is to make sure all the checks, everything is working. When you hop on an airplane, if you've ever seen, there's a lot of checks the pilots do to make sure everything's working. This is just like this, just a tad more. There's a few more things to check. It's not just the science. It's making sure the airspace is clear. It's making sure the surrounding land is clear. Now, it's making sure the flight trajectory is understood. It's making sure the winds, the weather, the science instrument, because if the science instrument for some reason isn't ready, the rocket's not going to launch, because the whole point here for this very first launch is launching what's called an X-ray quantum calorimeter. Now, this is measuring X-ray light from our Milky Way galaxy. Now, when you think of X-ray light, you think of broken bones going to the hospital. it's a little bit more complicated than that, but it's still the same type of light. And in fact, lots of things in our universe emit X-ray light. Black holes are popular at emitting a little bit of X-ray. There's a lot of X-ray emission or X-ray light that emits from the center of our galaxy. And that's one of the critical reasons why this mission is happening. So in particular, if you're looking at the southern parts of the Milky Way, where the center of our galaxy is located, and you want to understand what is this very energetic stuff emitting from our galaxy, you can only see that from space, because luckily our Earth's atmosphere blocks most of the X-ray emission. Otherwise, we'd be bombarded with X-ray radiation every day, and we probably wouldn't have humans here to talk about this launch. Now, what we will be seeing later is that preparation for that launch about to take place. And as we were just hearing from Kevin, so Kevin is one of the mission scientists. He's the whole program scientist for all 3 missions, but he in particular is focused on mission 2 called Sistine and mission 3 called Deuce. Now, both of these will be looking at ultraviolet light. So this is one of my favorite things. I like to use ultraviolet light to study stars that explode. What Kevin's team is doing is looking at ultraviolet light from something called Alpha Centauri. So if you go on a dark night in the southern skies and you look towards the Southern Cross, now, there's 2 bright stars near the Southern Cross, and we call those the pointers. And the brightest of that is Alpha Centauri. This is the nearest star to us. Now, it's 4.2 light years away. So a light year is kind of how long light takes to travel in a year. It's kind of used as a measuring tool. You can kind of use it as a time in some way. What's really important, though, here in astronomy terms is the light that has left that star took 4.2 years to reach us here on Earth. So it left that star 4 years ago and is only now reaching us here on Earth. So when next week, when Kevin is looking at these stars, they're seeing light as it was emitted 4 years ago. So they're quite looking back to what that star looked like in 2018. And they'll be using that information to see the properties of the star, the ages, maybe is there an exoplanet around it? This is a big topic in astronomy. Are there other planets around other stars? And Alpha Centauri, that nearest star to us, is a really important target because it is the closest thing that we can possibly have to us to study this, obviously.
Explorando el espacio estarán directo en el sitio de NASA con el anuncio del James Webb este 12 de julio. Imperdible.
I think it's kind of interesting, we were just having a few questions real quick, just to remind people. For those people who are tuning in to already see a rocket launching, we did have a 30-minute delay at the beginning of the show. And again, this is purely normal operations. So we're now just reached the T-27 and counting mark. So far, that is on track. For those who were tuning in earlier or watching this pre-recorded, you may have noticed we actually heard some rain above us. We've been fighting rain on and off a bit throughout the day. Rain is actually not that big of an issue. The winds so far appear to be cooperating, just looking at the person who's making sure everything's on check. So far the winds are behaving. The rain seems to have mostly stopped. And as of now, we are on track for Australia's first commercial launch and NASA's launch from a first time from a commercial spaceport. So we'll be doing that in hopefully 26 minutes. And as we get closer to the site, we'll be bringing you live images of that rocket taking off for as long as we want. And we'll actually be talking to some of the people on mission 2 and 3, because once launch 1 happens tonight, it doesn't stop there. The group starts tomorrow morning for launch 2 happening on 4 July, and then they get ready for the third team coming on 12 July. So we're gonna go see Kevin now in his
La misión lunar Artemisa 1 de la NASA completó un hito crucial antes de su lanzamiento. Lanzó un par de satélites con el objetivo de mejorar en los próximos días. Super Heavy B7 hacia la zona de lanzamientos y después de varias horas de preparación, el próximo mañanero espacial, entre otras. Y esto es todo por hoy. Recuerda darle like al video si te gustó y suscríbete si no lo has hecho. Nos vemos en el próximo mañanero espacial.
Which is always a trick, yeah. So the telescope is here?
That's right. So the telescope starts here. It points out this way. This is what we call the shutter door.
Yep. Oh, yeah.
If you see, it's on a thread here.
Yep.
And there's a hinge down here.
Yep.
And in flight, on a timer, this motor will run. It'll run the thread down and open the door this way.
Okay.
And look out, and the telescope will look out.
Yeah. So essentially,
tell
this
you.
is the bay door that opens up, and then you're looking out this way.
That's right. Yeah.
So then, so the telescope mirror width is maximized.
That's right.
Yeah.
It takes up the whole thing.
Yeah. I assume that was it.
It's a full half-meter mirror, which is so the diameter here is 22 inches,
Okay.
and the mirror is like 20 and a half inches.
Yeah,
So
okay.
it's as big as we can possibly go. I wanted to make these measurements of Alpha Cent, and we realized that we couldn't have done it with previous technology that you could have put on a rocket.
Yep.
And so we said, okay, well actually, if we use these advanced technologies, we can build this instrument that will have, throughput 15 times greater than what we'd ever been able to do before, and we can actually do this science even on a rocket payload.
Yeah.
And so we just, built it all together.
Nice.
Yeah.
Well, look, so far it seems like it's tracking well, at least.
Yeah. This is also this is the second science flight. We did a test science flight to observe an F-type star in November of last year.
At
from
White Sands.
Yeah. NASA did not want this to be the first flight of these payloads.
Interesting. Okay.
Yes, they wanted payloads that had a high probability of scientific success.
Yeah, okay.
Which I completely understand.
Yeah, no, you don't want 3 missions that go up and don't give data, because
that's right. This was a big investment, and so we wanted to make sure that we got the bang for the buck.
Yeah, no, that makes sense, right? I mean, because it has not just been you guys coming here; it has been
the whole
everything.
enterprise. Yeah, exactly. Which has been fantastic.
Which normally you're just dealing with the individual experiment, right? In terms of especially operating from the US.
Este próximo 12 de julio, la NASA va a mostrar las primeras imágenes de ciencia a todo color del nuevo telescopio James Webb recién terminado de comisionar. Nuestro amigo Darien, a quien vamos a acompañar en un directo, va a estar físicamente en NASA Goddard, acreditado, para darnos la primicia. Agendar el 12 de julio.
A much bigger undertaking, and so we wanted to make sure that we'd work the kinks out.
Yeah, no, I understand. Did you get data on the first flight?
It was beautiful. Yeah, we have my former my almost to defense grad student now is back at home writing the paper on
Nice,
that
cool.
thing.
Yeah. Awesome. So that is kind of the second payload that we'll start to see up close. Well, not for this launch, but on a second launch on 4 July. We'll then have the third launch on 12 July. Now, obviously, we weren't able to quite show the first experiment. That's because it was already loaded to the rocket. And once it's integrated with the rocket, that's what you're seeing here on the launch pad. This is the integrated rocket. Now, you can just make out the gantry. That is the metal support structure on the left. So that is actually what's holding the rocket in place. Now, this is a sounding rocket. Now, what we mean by sounding rocket is it goes into orbit, but it doesn't do a full orbit around the Earth. You can also see a few of the raindrops still on the camera from that beautiful dry season rain we had earlier, but it will be blown off when that rocket takes off. Hopefully we still keep the camera, but that's someone else's problem. Now, as that rocket takes off, on the right, you can see there's actually going to be different stages. And in a little bit, we'll go to an earlier shot that we had today of the rocket on the launch pad during the daytime, so we can see the different sections. There are multiple stages to this rocket. There are stages that involve the motor, i.e. the engine getting up. There are stages that just contain the science payload, and that's kind of what we saw in the lab earlier with Kevin. That is the part where the telescope, all the electronics, the equipment is. Now, the engine part, the motor part, is that first bottom part that you're seeing now attached to the gantry on the left. And again, we apologize for the kind of distortion of rain on the lens, but that's what's happened with the rain, and we can't obviously have anyone down there to dry it off because it is a working site and they are preparing for launch now just under 20 minutes. So we originally were scheduled for a launch 10 minutes ago, but that was pushed back through a 30-minute delay. I mean, sometimes you just have to delay things. But luckily, it's only 20 minutes to go, not even that, before we see this launch take place. Now, when you look at this rocket, what you'll see is when it launches from our shots that you'll be seeing later, it will be launching towards the southwest. So as viewed from now, it's going to be going slightly off screen to the right. Now we'll have further cameras back that will follow up for as long as we can. Now, this rocket actually does move fairly fast. Because it is a small sounding rocket, it does actually move quite quickly, accelerating on that initial go. And now, sounding rockets are actually quite common. We're kind of used to these giant rockets, but a lot of these missions at places like NASA Wallops facility, who is the partner with Equatorial Launch Australia, they're the customer here launching this rocket or having the rocket launched. They do launch from all over. They've launched from Alaska, White Sands, New Mexico, Svalbard in Sweden, and almost everywhere in between. This is their first commercial launch anywhere, though. Usually when they've launched, it's been a government or national or military facility, so to speak, something not operated purely by a commercial entity. And I think that is part of the story and legacy about what we're seeing tonight. And that is Equatorial Launch Australia's vision was, if you build it, they will come. If you build a great facility that has all the requirements for what a rocket wants, you will have customers like NASA wanting to come to your facility. Now, it's not easy. When you build a spaceport, you have to have a few different bits of infrastructure. You need to have communications. You need to have data. You need to have electricity, power, places to houses. You know, you're building in somewhere that is one of the remote locations, not just in Australia, but probably in the world, and you're building some of the most sophisticated experiments that scientists and engineers can do. Now, one of the great things about that is it prevents and gives unique possibilities. It prevents interesting challenges as well. And I think the team here at Equatorial Launch Australia has been working around the clock to make sure this facility is up to scratch, to make sure everything possibly that you can think of, rethink of, check and recheck is done to make sure this launch has happened. And to make sure that when that rocket launches in now under 17 minutes, that when it goes up, the scientists, when they take over at 100 seconds, because that's the rough timeline, 100 seconds in, as the rocket's gone up, that's when science starts. That's when you start to reach enough altitude that the science can happen. Now, for those who didn't hear, the rocket will reach a peak altitude of about 350 kilometers. That's the planned apogee or height of the mission. Once there, that's when all of this that's when science starts. That's when you start to reach enough altitude that the science can happen. Now, for those who didn't hear, the rocket will reach a peak altitude of about 350 kilometers. That's the planned apogee or height of the mission. Once there, that's when all of the science happens. Now, afterwards, after that rocket goes up, the bits of the sounding rocket experiment will come back down. They will be parachuted safely back down to it. It's going to land. You have to recover it. Now, part of this story is that when you're working with this, they're working with so many different people. Yes, they're working with NASA. Yes, they're working with the scientists. Yes, they're working with the team here. You have people from the Australian Space Agency making sure everything's working. From CASA, the Civil Aviation Authority for airplane traffic. You can do that. But the science of actually getting a rocket into orbit is more than just the rocket itself. And I like to emphasize that point. There are people here from so many different backgrounds and skill sets to make this happen. And this is the broader part of it. Can you build a rocket company and not know anything about economics? I'm an astronomer, that's my background. I like to study supernova. I only have to be accurate to within about 1 billion years. That doesn't make for a very good job in other cases if I have to say your bank account's good to within $1 billion. I probably wouldn't keep a job. You need those people to be accurate. You need those people to be skilled. So you have so many different people from so many different backgrounds and skill sets from all over Australia. Quite literally, there are people from Ballarat, Melbourne, local, Darwin, and anywhere in between, making sure that this launch has had all the equipment necessary to be successful. And one of the part of that story is working here from them now. So I'm here with Jawa. Thanks for joining and having us here. Where are we? And we know we're at a rocket launch site, but this is the traditional country of the Yolngu people, correct?
It is the traditional country for my clan, the Gomach.
Yep.
And we're at a place called Korkula.
Korkula, okay. Oh, and now sounding rockets are actually quite common. We're kind of used to these giant rockets, but a lot of these missions at places like NASA Wallops facility, who is the partner with Equatorial Launch Australia, out here, aren't there?
Here there are about 13 clan groups.
Okay. Yep.
I'm one of my clan is one of the 13 clan groups.
Yep. Okay. And so you've been working with Equatorial Launch Australia?
Yes, we have. When the moment came for the scientists to come and talk to us, we just thought it would be a great idea to get something like this to do, looking at how our future would roll out.
Yeah, so so you see this is kind of a great future for the local people here.
It is, absolutely, because the mine here won't last long, in another couple of years, I guess. And but seeing that we have talked to ELA and NASA about the rocket or the space center here, it brings that, especially about the town, if it is to fade away or die, we have hopes that it will stay alive.
So this is kind of the future, that life support almost of working with other groups to take the next step for the people here.
The next step is it's the future, not only for us, the whole town, and for whatever the potential of the scientists coming and working amongst the Yolngu people here, especially the Gumach.
And I think that's the beautiful thing, as you just said, right? Working with and amongst. It's not working for that. And this is I think the beauty of what's kind of being formed out of the Arnhem Space Center, right? Is this partnership to grow not just space in Australia, not just space in the US, but space here, and that beauty of it.
That's right, because my tribe, the Gumach, are always in the lookout for, we look over the horizons and see what we can, utilize our country to be able to use it in a way that it can become, economy-wise, kind of thoughts that we always have.
And so, you get to drive the economy drivers, and I think this is beautiful connection. I love standing amongst this beautiful red dirt, and then we think about, connecting to the skies, right? And that's quite literally what is happening here.
That's right, because we, with NASA and ELA, and we like to work. This is the only way that we can work in collaboration with scientists as Yolngu people, because Yolngu people, especially us and another clan groups, we tend to not forget about the stars in our kind of dreamings and all that.
And if you're just thinking, this is the first, obviously, of 3 launches scheduled, but what is the hope for the future? Do you hope, and does your clan hope that this becomes just a bigger business industry, so you have multiple launches happening?
I'd like to see that in the future.
And
if like NASA or ELA want to expand all this, we are happy.
I mean, I think that's a beautiful thing, because I think I'm obviously not from here. I'm from Ngunnawal country down in cold Canberra, enjoying the beautiful warmth of the sun for once. And I think this is the thing, is being able to also have other people come and appreciate the beautiful country out here. You have people from the US and all over Australia, and I think as multiple launches happen, and is there that possibility of that bigger growth, not just for the science, but for tourism and people learning about the place and the beautiful country out here?
Yes, especially with tourism. The Gumach people are in the early stages of tourism being out here, but other clan groups have opened their country for tourism, and the Arnhem Space Center here would be the ideal place for tourism in the long run.
Yeah, I mean, I could just dream and think about, kids and people from all over on school holidays saying, let's go up to the Arnhem Space Center and watch a rocket launch and enjoy the beautiful country up there.
And the school holidays have started already. And the kids are always asking me at my community, hey, Jawa, when do we go out and look at the rocket take off?
So is a lot of the group in the town going to come out and watch the launch from a safe distance?
Yeah. but like better be in the safe distance rather than being in where the actual the launch will take place.
Sometimes, yes, it's nice to appreciate beauty from afar rather
than being here in the middle of it.
Well, look, I think it's great that you've welcomed and opened everyone up to being here and working with you on developing this amazing, I think, potential for everyone, as we just said.
Yeah, but like my thanks is to the Northern Territory government, the Australian government, and even if I have to say thank you to the American government as well as.
Sometimes we have to.
Yes, we have to.
And so, is there, on this process, has it been one that's taken a while, or does it happen overnight? I think people view it as this quick process, but I imagine it's taken some work.
It has taken time, especially with the consultations that have taken place with the local statutory body, the Northern Land Council. I have been to a couple of places and looked at the other communities in how this will affect those. But all of them have come back saying they've supported all this.
I think this is great. It's that it is just really this country national effort to make this happen, and hopefully we'll see a beautiful launch take place, one of many that will happen here at the Arnhem Space Center.
But like I mentioned earlier, we're looking forward to all this, and especially my clan, the Gumash.
And so there kind of is this excitement and buzz, I guess, across
all around.
Yeah.
In the town of Nullarbor, everything's a buzz. Yirkala and Ski Beach, where I come from.
Okay. What I think could be almost remarkable to think about is a rocket taking off, going to Mars, connecting one beautiful red country to the red planet. And I think that's one of the potential that this site offers everyone.
It is possible. If we have that feeling towards the potential of rockets going up to Mars, this is the place.
This is the place.
This is the place.
And this may be the first start of that place.
This is only the beginning of a new beginning.
The new beginning. I love it. And so it was great to really chat to Jawa earlier in this launch. Now, as you may be hearing, the rain has returned. Now, this is not stopping the launch as of yet. We are still just 4 minutes and 35, almost 30 seconds from this launch. Now, one of the reasons why the rain sounds so heavy here is just the nature of the roof. It is not necessarily as pouring as it may seem, though I'm obviously inside and not outside in the wet rain. I will keep talking as loud as we can to keep going. Now, we are still at the countdown as we're going. We have not changed this procedure. It all depends on the rain, and it all depends on what the wind is doing. The countdown is still going. They are still now just approaching 4 minutes. Now, hopefully this rain won't last very long. They may have to cut it. So generally what they will do is pause at 3 minutes if there has to be a delay due to small bits of rain. So we will keep going probably at least until 3 minutes. We'll tune into launch control to see is it delayed or not. Now, weather delays are a natural part of the beauty of launching a rocket. It happens anywhere. It happens in Florida. It can happen anywhere. Look, if we're going to consider the positive, the rocket's going to be nice and clean. Now, it's sounding very heavy in here. Now, people may have noticed I'm a tad excited by this. Now, I am a scientist. My specialty is looking at stars that explode and how the universe evolves. Hey, the rain's stopping. There you go. That's the great thing about the weather. I am excited to see this rocket. I have never seen a rocket in person. I've seen videos. I've seen stuff happen from rockets launched into space. I've never seen it here personally. We're stopped. So we have now just stopped at 3 minutes, so we will pause the counter. Now, again, this hold is purely due to the local weather. There hasn't been any changes in anything to do with the technical side of the rocket. There hasn't anything to do with the nature side of the rocket. And so, yeah, we will pause the countdown in a second, but we are on hold at 3 minutes. So we will reset the counter to 3 minutes, and this is purely due to the weather. Now, the great thing about the way the weather is happening here is it's not like there's a massive storm that is happening repeatedly. There does appear to be local pockets of just rain coming about. So it's a mixture of rain, obviously, that they're worried about, but the wind. Now, one of the things that will happen is there is a launch window for this. So it's a 3-hour launch window. So we do still have plenty of time to see this. So as long as the weather essentially subsides at some point, we'll be okay. Now, you can't really see that much outside. We can see a bit of the glow of the clouds and a bit of the glow of the rocket. But you do notice that there are some raindrops on the camera. Well, it is outside to catch the launch of the rocket. You can just see the light bit of the base there. Now, again, for those who are just turning in, this is a sounding rocket. So the rocket is 22 meters in length. It's about 2 tons. The experiment is carrying is an X-ray measurement to look at the X-ray gas from our Milky Way galaxy. Now, one of the great things that we were able to do is to get up close to this rocket. And this happened earlier today. And this was actually really momentous because, you know, to build a rocket, you don't just put it on a piece of dirt. There's a huge, what we call, launch pad. This is where the rocket launches from. This had to be bolted meters, over 14 meters into the ground. Had to be secure because as that rail goes up, as it's already in its position, as the rocket is up and ready to go into its position, you need to make sure it is secure. You need to make sure that it is safe. And you need to make sure that gusts of wind don't knock it over. The last thing you want is a gust of wind or anything like that to knock it down. So one of the other parts that was quite momentous yesterday was the full dress rehearsal. So we said the countdown started almost 8 hours ago. Now it's actually closer to 9 with these weather delays. Yesterday, there was a dress rehearsal of 8 hours. This is the process it takes to make sure everything is operating smoothly from a technical side, an engineering side, weather, safety, checks, you name it, they had to do it. And what was special about yesterday was as the rocket went from its vertical lying position to its, or horizontal lying position rather, to its vertical straight up and down position, all of the team, the ELA team who's been working weeks non-stop to months and years, the NASA team who has come out here, all 70 plus personnel.
Este próximo 12 de julio, la NASA va a mostrar las primeras imágenes de ciencia a todo color, del nuevo telescopio James Webb, recién terminado de comisionar. Nuestro amigo Darien, a quien vamos a acompañar en un directo, va a estar físicamente en NASA Goddard, acreditado, para darnos la primicia. Agendar el 12 de julio. Estamos viendo el lanzamiento de un cohete Black Brant IX desde Australia. Es suborbital y lo lanza NASA, mide casi 12 metros y lleva una carga de 90 kS a 350 kilómetros de altura. En este caso, aunque puede llegar a los 1500 kilómetros.
You have to do is obviously the rocket starts lying down in the shed, gets into the launch position, ready for takeoff. So we're at the dress rehearsal now, but it'll be put into position tonight for the launch, and soon it will take off. Yeah. So that was a little bit of the rocket up close, but we have actually plenty of vision that we shot from near it. Now, the rocket, as we were kind of seeing when we went into the PIF, as it's called, this is the facility where the instruments are stored. There are multiple stages to the rocket. So you first have the bottom rocket motor on the bottom. Now, this is the workhorse of the rocket. This is, when you think of rocket, this is that bit. This is the engine that obviously will take it into space.
Este próximo 12 de julio, la NASA va a mostrar las primeras imágenes de ciencia a todo color del nuevo telescopio James Webb, recién terminado de comisionar. Nuestro amigo Arnhem, a quien vamos a acompañar en un directo, va a estar físicamente en NASA Goddard, acreditado, para darnos la primicia. Agendar el 12 de julio.
And I kind of like that idea that one day in the future we may have a rocket leaving this beautiful red dirt going to the beautiful red dirt of Mars, for instance. Now, as you're actually seeing that building on the left, that's where we're broadcasting from. Down the road, you can see at the end, you can see the rail just in that previous shot of where the rocket was. Now, this is what it's like right now. Obviously, we're in the nighttime, but this is the position of the rocket. It's in its vertical position. So it comes out of the housing, moving from that horizontal to vertical position, being locked into place. And it really was momentous yesterday when all of the team was able to get there and see it up close and personal. And you know, when you have a rocket launch, there is a huge amount of people who have to make it happen. And when you look at the different parts of this, you have the engine, you have the motor, as you're seeing. So you have the rocket on the left, or the right rather, the gantry, the support structure on the left. You have the science payload, as you're seeing in the middle, going to the top. This is the bit of the rocket that makes the rocket what it is. And some of the people you're seeing are these people who have been working non-stop, I think it's fair to say, for weeks to months in some cases, making sure of it. Sometimes you have to get underneath the pier of the rocket to make sure everything's working. And normally it is a smooth sailing operation. Now, we are in a T-3 minute hold. Again, we are purely in a weather delay hold. Now, we are in the Northern Territory. We're at the Arnhem Space Center, and we're in a place, or a time and place rather, where we're in the dry season. This is supposed to be where the weather is fairly consistent day to day, where the temperature is pretty much 28 to 30 degrees Celsius every day, and stays like that. That is not the case right now. We've obviously had some rain impact. Now, the rain has stopped. That is the good thing. When the weather is resumed to be stable again, they will initiate the rest of the countdown. And this is why you have a T-3 minute countdown. This is purely because all of the other checks are here. Everything else is ready to go. We're only waiting for the one thing that no one can control, but everyone would like to, and that is the weather. You know, one of the things I get to be asked all the time as an astronomer, I use telescopes to look up, is, well, can you look through clouds? No. There are so many weather anomalies, we'll call it anomaly, that stops us. Wind, rain, storms. In this case, it is the gusting wind that is blowing in with this rain. Now, again, it has stopped, but there does need to be enough stability to make sure that it is in the safe parameters. And in fact, you can see on the camera there are a few raindrops on it. Again, keeping in mind this camera is outside because we budgeted for the dry season, not the wet season as it's apparently turned into this afternoon and evening. But nonetheless, once it is deemed safe.
Copy that.
So we have just started count again. That's why we want to see. Now, that is the amazing thing of being in the operations center, is when you deem the weather's good, we are good to go. So now we are resume counting. We are ready to go. And as long as we don't get another storm, we're going to see a rocket launch. Now, what we will be doing is for going outside soon to see the rocket launch. So we're going to stay mostly on these shots near the launch pad, and we'll be seeing it as it takes off. We'll be then panning to an outside shot for the launch taking off, and then obviously as far as we can see it. So as of now, the weather seems stable enough that we're good to go. We've just approached less than 2 minutes. We are on track, so we're minute 45.
No, te me sale casi.
Copy hold.
So we've just started another hold. We'll see what that is about. Now, again, everything is just making sure that the weather conditions here are stable enough for it. Look, you know, imagine it's Christmas, right? It's no good just to open all your presents once. You want a little bit of anticipation. Well, you're getting it here tonight. We said it'd be history in the making. Making sure you're earning it by staying tuned to watch this. Now, we do have the current problems with winds. This is where we're at. The official hold time is going to be 2:01. So this is going to be our official time. We will set the count based on that clock. We're just making sure everything's syncing together. So we're at a 2 minute and 1 second hold. Now we will keep on that. We will stay at 2 minutes and 1 second until we resume it. We won't go back to that 3 minutes. Right now, everything they're doing is just making sure the winds are cooperating. So again, for those who are just tuning in, hoping that the rocket has already taken off, we've been dealing with some storms blowing in during the dry season up here in the Northern Territory, waiting for it to, well, subside essentially. Now, as of now, the winds are not dramatic, but they are out of tolerance for the rocket. So what that means is there is enough gust that the rocket is swaying too much. Now, as we were seeing in those previous shots, the engine and the rocket is mounted to the gantry, and that has to be stable. Now, because of the wind, they're going to reset to 3 minutes. And again, this is all part of the normal process. And again, the only thing stopping us right now is wind and storm. So for everyone, think good thoughts in Australia. Absorb all of the bad weather here so that we can see this rocket launch and this rocket takeoff. And again, I mean, you know, we are all excited to see this historic first commercial launch. We're excited to see NASA's first commercial launch from anywhere. So we will be monitoring the weather. They will be staying it. And as soon as, again, the winds are in that tolerable range. So what they're worried about, again, is the gusts. So how much you can gust back and forth. That is the real worry here. This is going to be what is going to prevent or start our count. Now we have a plenty of time in the launch window. We have a 3-hour launch window. Now that is started from our original time to which was about an hour ago now. So we still have at least another not quite 2 hours to fit the launch in. So there's not necessarily that much of a worry for the rocket not taking off, so to speak. But we're just waiting for that wind to die down. And once the team at Launch Control Center, that's the building kind of behind us, that will be essentially pressing that button. Once they are ready to go, we will be ready to go. And we will be with you. We will be with you until we get that 0 mark. When we hit 0 and we see the rocket launch, that's what we all want. That's what I want. That's what you want. That's what the team here wants. You know, there are scientists who have been waiting for their experiments to go up and launch and get their data. And, you know, they've been hanging around for a long time. They've been long for a bit. Now, one of the things that is, I think, exciting about what we are seeing is really what the science we can expect from some of these missions. And so we're going to go, for those who missed it, we're going to go back and play Kevin. And so Kevin is one of the mission scientists that we were able to see and talk to about why did NASA come to see this rocket launch happen? Why did they want to do their science? And why are they setting up here? So we're going to try and go see Kevin again. Again, this is pre-recorded vision, and Kevin is relaxed a bit because right now he's on the 2nd and 3rd mission. He's just waiting out for the first launch to happen so he can see his 2nd and 3rd launch.
If there's a little bit of residual gas in there, you can actually create an arc that goes across the small amount of gas. It'll act like a conductor.
Yeah.
And if that happens, then things can break down and melt quickly.
I can imagine that.
If there's a little bit of residual gas in there, you can actually create an arc that goes across the small amount of
Yeah.
gas. It'll act like a conductor.
Yeah.
And if that happens, then
Well, we're
things
now
can
resuming
break
the
down
count.
and
This is
melt
the
quickly.
beauty of trying to launch a rocket in the dry land.
So there are all
the
sorts of inhibits on here
winds
to
have
not
been
let
deemed to be
the
within the
detector turn
safe
on
region.
if it's not
We
at
are
high
now
vacuum.
going to resume
In
it.
fact, we actually,
And
during
now,
flight,
if it's going to be
we take this,
so
when
far
we're,
on
when we're
track.
arming the vehicle, we take this
Look,
plate off and we put a
everyone
little
who has
cheater
been
plug in there
staying up for
that
the
allows it
stream,
to
I
override
really
that-
appreciate
that
it.
circuit, so it will turn
you
on
know,
in flight no matter what.
I am dedicated to seeing this
It's
launch
very
happen.
dicey
I will
because if
be here
somebody
till we get this
accidentally
launch
turns it on,
happen.
it would be
You
very
will
bad.
be here till we get this launch happen,
it's like-
because that's what
it's
everyone
only-
wants. Now, the count is officially on. We are resuming as we were. And as of now, the winds seem to be deemed in the safety range. We're just double checking that aside. But this is the official call, which means if nothing changes, we're only a minute 50 from our very first launch. So if we go back outside to what the rocket is looking at right now, there will still be some raindrops on the screen. That's not surprising. Unfortunately, there is not much we can do at this point. But we have plenty of camera shots that will see it, and we will see the launch take place from here. We will also see the further panned out cameras as the launch takes place. So this is going to be our wide shot that you can see. You can see the base of the rocket glowing at the bottom. We're a minute 23, and you can really start to feel the buzz and excitement now. Everyone who is in this room right now is abandoning me. I'm being abandoned ship because everyone's going outside to see a rocket launch. This is going to happen. We are just now a minute 10 from Australia's first commercial launch that we have seen. You know, there is a real buzz from everyone running outside, NASA employees, government representatives, the ELA team. So the winds have just popped up again, unfortunately. So we're holding now at 58 seconds. We will see if we resume this countdown. You know, this wind, I am going to be happy if I never hear of wind again. I'm going to tell you this right now. So we will reset. We're holding at 58 seconds. Let's hope that the winds keep down enough. So we're going to reset now to 3 minutes. So this is the process that once the winds are deemed too high, we have to reset to the 3-minute clock. Now, unfortunately, this is because of the whole process of counting down. Because once the rocket is launched, it obviously has to take off. So the worry about the winds is not just for the rocket itself on the launch pad. It is for as it goes, obviously, into its orbit as in a trajectory. And if the winds are blowing it around too much, it could be blown too far off course. It can limit the payload being reached into orbit, and this creates a lot of problems. So we're going to restart the countdown back to 3 minutes. Luckily, we're not going past 3 minutes at this point. It's just a wind problem. We're going to stay at 3 minutes for now, and as soon as we can, we will resume the count. Now, again, I appreciate everyone being so patient with us. You know, this is the weather. This is what life is like when you're trying to launch a rocket. You know, hey, they say it's rocket science. In fact, on the back of the bottle, it is just rocket science. But what we're doing is we are just waiting. We'll stay on these shots, obviously, for the wide shots. Do you want to? So, but what we're going to try and do is at least get a sneak peek back about what Kevin, as we were talking to earlier, was excited by. Sorry, we are just trying to make sure everyone's at the right 3 minutes. Oh, thank God, I need a drink.
And if that happens, then things can break down and melt quickly.
I can imagine that.
So there are all sorts of inhibits on here to not let the detector turn on if it's not at high vacuum.
Yep.
And in fact, we actually during flight we take this when we're arming the vehicle, we take this plate off and we put a little cheater plug in there that allows it to override that circuit, so it will turn on in flight no matter what.
Oh, okay.
But then it's very dicey because if somebody accidentally turns it on, it would be very bad.
Yeah.
So it's like it's only held safe by humans at that point, which is the scary thing.
Which is always a trick, yeah. So the telescope is here?
That's right. So the telescope starts here. It points out this way. This is what we call the shutter door.
Yep. Oh, yeah.
If you see, it's on a thread here.
Yep.
And there's a hinge down here.
Yep.
And in flight, on a timer, this motor will run. It'll run the thread down and open the door this way.
Okay.
And look out, and the telescope will look out.
Yeah. So
at the
essentially, this is the bay door that opens up, and then you're looking out this way.
That's right. Yeah.
So then, so the telescope mirror width is maximized.
That's right.
Yeah,
it takes up the whole thing.
Yeah. I assume that was it.
It's a full half-meter mirror, which is so the diameter here is 22 inches.
Okay.
And the mirror is like 20 and a half inches.
Yeah,
so
okay.
it's as big as we could possibly go. We wanted to make these measurements of Alpha Cent, and we realized that we couldn't have done it with previous technology that you could have put on a rocket.
Yep.
And so we said, okay, well actually, if we use these advanced technologies, we can build this instrument that will have, throughput 15 times greater than what we'd ever been able to do before, and we can actually do this science even on a rocket payload.
Yeah.
And so we just, built it all together.
Nice.
Yeah.
Well, look, so far it seems like it's tracking well, at least.
Yeah. This is also the second science flight. We did a test science flight to observe an F-type star in November of last year
At
from
White Sands.
Yeah. NASA did not want this to be the first flight of these payloads.
Interesting. Okay.
Yes, they wanted payloads that had a high probability of scientific success.
Yeah, okay.
Which I completely understand.
Yeah, no, you don't want 3 missions that go up and don't give data, because...
That's right. This was a big investment, and so we wanted to make sure that we got the bang for the buck.
Yeah, no, it makes sense, right? I mean, because it has not just been you guys coming here, it has been
the whole
everything.
Enterprise. Yeah, exactly. Which has been fantastic.
Which normally you're just dealing with the individual experiment, right? In terms of, especially operating from the U.S., where here, for these 3 missions, it is, the whole enterprise of the facilities, getting him here.
Exactly, yeah. And when we launch in the U.S., we basically just plugging our experiment into a process that is already happening.
Yeah.
Here, we've created the process.
Yes, exactly.
And so it's just a much bigger undertaking, and so we wanted to make sure that we'd work the kinks out.
Yeah, no, I understand. Did you get data on the first flight?
It was beautiful. Yeah, we have my former my almost to defend grad student now is back at home writing the paper on that data.
Yeah. Awesome. 40. So, if you've just seen, we have resumed the count. And that is because, yes, the winds have now become, stable again. So we're going to try and see if we can do this again. And I appreciate everyone. Yes, I need a drink. I'm only fortunately drinking water because my voice is very sore. But you can do as much as you want at home. Hopefully we don't have to go back to that 3-minute game. So we are now just
el primer lanzamiento, previsto para el 26 de junio, llevará el calorímetro cuántico de rayos X, o XQC, de la Universidad de Wisconsin, Madison. XQC llevará detectores de rayos X únicos, enfriados a una gélida 20ª parte de 1 grado por encima del cero absoluto, para medir los rayos X interestelares con una precisión sin precedentes para comprender mejor el medio interestelar y su influencia en la estructura y evolución de las galaxias y estrellas.
And we are going to see a rocket take off from Australia. 30 seconds. Now, the fact that we are having a rocket take off from Australia is just as... I cannot wait to see 20 seconds from now this rocket take off. So we have now held again. So I am sorry for this fun game. I promise we are not playing a trick on you. The winds are playing a trick on us. We were so close. We were so close. We will get there again, but we will see. So we are on hold. If it is a wind hold, we'll go back to 3 minutes. If it's something like that. So we are going back to 3 minutes yet again. For those who suggested drinking every time you hear 3 minutes, I suggest taking a drink as well. Now, I'm obviously just drinking water, but in order to wet my whistle, so I'm going to keep being with you until we sing take off. Look, at least we're getting closer every time, right? You know, we're slowly inching and inching and inching. And look, again, this is quite uncharacteristic. You know, this is the dry season of the Northern Territory. We are not really expecting rain. We are not really expecting wind. And you know what? I'm glad you're having fun with this. Look, this is what it's about. We are having fun. We are excited. I'm still going to be excited. And I'm trying to keep up to date with all your comments. I could be playing a trick on you. We could just be looping this. We could be a slight Truman Show type thing. But no, this is real. The rocket is still on the launch pad. We are still ready to launch. We are just holding for T-3 minutes. And waiting for the winds to go. And I'm kind of actually just being laughed at this point. 1 second. Oh, we were just seeing if we were getting resume countdown. We're not. So again, this is just all allowed for the wind variation on the rocket relative to the gantry. So we're just checking on the timing to make sure. Yeah, so we're still going to be at 3 minutes. We're just making sure. So it is science, it is rocket science, it is weather, it is patience, it is excitement, it is everything. Thank you for everyone for staying with us. Again, so our launch window, we had a 3-hour launch window. We still have plenty of time in this launch window. And I am going to be here until we see a rocket launch. I am not leaving this room until I am strapped to something. Maybe it's a rocket, maybe it's someone dragging me out. We are seeing a rocket take off tonight. We are excited. We are ready. We will get the weather cooperating. So we're going. Yeah. So the official count, we're just being informed. We did get to officially 8 seconds, but we had to restart to 3 minutes. And again, this is all just the. So we're just doing.
Copy that, confirming balloon test. Thank you.
So NASA has decided, so what they're doing is a balloon test. So now the idea here is they actually want to just make sure they test that higher level wind to make sure it's all performing as expected. Because again, it's all about the winds, it's all about the safety, it's all about that. So now because of this, because they want to be extra secure that they know what the wind's doing, that they know that the wind is going to be stable throughout, we're going to unfortunately have to go back to a longer countdown. So we're now going to go back to T-minus 10-minute countdown. We're going backwards in time. Now, this is purely to make sure that the wind is doing what it's doing, that it is cooperating, and that we're doing it. So yes, so those who are saying that we're going to be doing a balloon test, we are going to be setting it up. And for all of you who are keeping their kids up to watch this, I live in Canberra, which is a half-hour behind in a very cold place. I know my kids are watching right now. So you know what? Stay up. It's fine. Your teachers can deal with you in the morning. It's not my problem. Now, what we're going to be doing is we're going to be waiting. This is a momentous occasion. This is Australia. This is history. And, you know, we're going to be waiting here to make this happen. Now, one of the things that we were going to do is it was great to be able to see and interview some of the people on site. We were able to see the science. Yep. So what we're doing, so just getting the official text. So we're going to still stay at the T-3 countdown. So that's the official countdown. And the way procedure starts is we're just waiting for 10 minutes. And again, this is what we're doing is NASA's going to be launching a balloon up, getting ready to test those higher level winds. And so what we're really waiting for is just to make sure everything's cooperating. Look, and for those who maybe this is your first launch, maybe this is your 100th, this is common. We often get weather delays for places. One of the great reasons why people wanted to come to the Arnhem Space Center is because hopefully you can get something called the dry season. Well, the dry season is making every single person at the facility work for this launch to make sure what is going to happen and to make sure they earn that rocket launch happen. And this journey has been happening for a long time. And we caught up with Michael earlier in the day, who is the chairman and CEO of Equatorial Launch Australia. He really was instrumental in getting this facility to happen. And hearing the story about how you go from an idea of building a rocket to now getting a rocket almost ready to launch. We're almost ready to launch. It's a kind of an amazing story. And so I just want to play back that story, the interview that we had a chat with Michael, and because it's an important one. When we think about where we are, how remote we are, what this vision is, it means a lot, not just for ELA, but it means a lot for Australia as well. And this is a sort of amazing thing to happen. So look, we are going to earn it. We're going to make it. And yeah, for those who are counting, when we get to those final 10 seconds, I am going to be louder than anyone can tolerably imagine, because I'm going to be excited to see the final 10 seconds happen. Now, so we are, as we said, in this T-3 minute hold, rather, but we're in this hold for a few minutes while NASA launches a weather balloon. Now, unfortunately, we just don't have any vision or data from that, so we will wait to hear until NASA says so. But we are going to catch up with Michael, who we interviewed earlier in the day.
Hi, I'm Michael Jones, the Executive Chairman and Chief Executive of Equatorial Launch Australia. And tonight, we're doing Australia's first space launch from here in Arnhem Land. So watch this coverage and you will see the first commercial rocket launched into space from Australia, and the first time that NASA has ever launched from a commercial spaceport ever.
So here with Michael on what is, I'd say, a momentous occasion. Today is a small way of describing it.
Yep, every interview so far has asked me, how's the excitement level? Have had no excitement, just been too busy. But today, starting to get a little bit of a vibe that, oh, today's the day. So the excitement level is increasing a bit. So that's good, because I want to enjoy it.
Yeah, I was going to say, that's the thing, right? I mean, because this process has been not just the past few weeks or past few months. This process has been quite literally years in the making.
This has been an exercise of 7,000 cuts.
Yeah.
We submitted the start of our launch license about almost 2 years ago to the day.
Yep.
That's been a long, arduous process. The building of the site here and doing anything in a remote location is challenging. And of course, if you're going to be in an industry sector, let's pick one that's really sort of nice and simple, like space. Okay?
Yeah, exactly. It doesn't need any sort of technology involved at all.
No, that's right. And you don't need to find people who know anything.
Exactly.
Right? So, so we've had some challenges and it's been a long road, but, you know, despite like feeling on occasions that every roadblock in the world's been put in front of us, you know, we've got here, it's a great day, and you know, we are starting to get excited about it.
And I think there's just a buzz that you're starting to see amongst, as I said, not just you, but everyone who seems to be working here. You know, there are people who have been, you know, we were talking to someone, he's been working here on site for the past, 12 weeks. He's like, I just want to see the launch tonight, right? You know, I just want to get to that moment.
Yeah, I don't think we did it on purpose, but I think what you do is you leverage what the end game is all the way through these things. So everybody starts to get a feel for, I want to get to the end and I want to see, what this is all about. And what's a really interesting dynamic is the mix of, the 75 years of experience of NASA and all the people who are just insanely professional. They're so good at what they do.
I mean, and they're so regimented and, rehearsed.
Some could say inflexible, but let's just say they're very structured in what they do.
Yeah.
And then on the other side of it, it's us. We're here, we're sponges. We're trying to soak up every bit that we can from them, and you could not want, as a startup company, to have a better launch customer, pardon the pun. It's pretty hard to do these conversations without, working in this space and the launch customer.
But that's part of the job. That's the beauty of the job, right? It's the puns.
So we couldn't have a better customer to start off with because of both reputation, skill, and just their generosity of passing on information and working with us. And at the end of the day, there's this one guy who has to finally decide, are we going to launch? And that guy looks like me. So, so I have to remind them of that occasionally.
and it's also not the responsibility just to the people on the site or NASA or the science payloads. It's, in some degree, the entire community, as we've talked about, who's been invested in this.
Huge span of stakeholders, from you know, the Northern Territory government have been really instrumental in getting us off the ground, all the way through to all the different traditional owner and Indigenous groups who we want to engage with, but we have to engage with because we're on their land. Yeah. And specifically for these 3 missions, the payloads are landing back on their land, so we have to coordinate with them. And there's then the absolute myriad of interagency things that you need to do, from explosive ordnance, environment, transport, aviation, maritime.
Could you have people around CASA, the space agency, safety, site rangers? You know, it's not just rockets. You know, this is going to be the first commercial launch in Australia, and that means a lot for the Australian space industry, not just ELA.
Yeah, as I've travelled around the globe in the last sort of 12 months, talking to all the major players in the space world, one of the things that has really struck me is there are Australians everywhere. Yep. And so, to some degree, bringing that home and showing that we have a capability here, right. And this is our coming out party in a big way. And to show that Australian technology and innovation and entrepreneurship can, you know, be at the forefront of the world stage in space is a big statement. And I think that there are a lot of other great Australian companies in space.
There is.
But, you know, the Fleet Technologies who are doing satellites, the Skycraft in Canberra doing satellites.
Who will hopefully have another launch this year.
Yeah,
that's right.
and Myota. You know, Southern Launch, our launch partners who are coming up tonight, which is really nice.
That's right, and hoping to have that, you know, this kind of same facility, but in the south. And that's the beauty of it, is this isn't just representing this site, it is what Australia is going to become.
But certainly with Southern Space, we talk to it, Southern Launch, sorry, we talk to them all the time. We get on really well with them because we have common problems, you know, and common challenges. So we try to help each other out where we can, and I'm a big believer in, you know, the sum of the parts is always going to be, you know, the best part of it.
And so, you know, let's 10 years. We have a first launch tonight.
Yep.
What do you think Arnhem Space Center looks like in 10 years?
Well, where we're standing at the moment is on what I would call, you know, Site 1. Yep. Yeah, the end of the first phase, which gives us the ability to do medium-sized rockets. Yep. So up to about 450 to 500 kilos in payload. Yep. The rocket itself sitting on the pad can be up to, you know, 200,000 kilos sitting on the, so reasonably large. This is Site 1. Yep. Immediately, you know, a kilometre, you know, to our east here is Site 2, and we will eventually have, you know, the drawing at the moment has 24 pads on it. Yep. It has to be very carefully planned so that we can do a launch effectively every 6 to 9 days. Yep. And so tonight, it's all happening tonight, right? Yep. We're now inside the countdown. We started the countdown at 8 hours before launch. Yep. There's a whole bunch of activities. It's incredibly detailed and scripted what happens, the number of checks, the number of players. There's over 100 people on site. All extraneous, non-required people are off-site for safety, but they're working through the checks. They're rehearsing, you know, as they go and then executing. We have to have a huge amount of external communications as well. So airspace, maritime, local emergency services, coordinating with security, just talking to everybody else on site as to what's... Because it's still a rocket that is being launched tonight, right? That's the thing. Absolutely. You know, we're about to fire a projectile that's going 300 kilometres into space. Yeah. And then it's coming back to exactly where we want it.
Minute, T-minus 3 minute hold for this weather balloon. Now the idea here is to have the weather balloon go up, test the local winds, because again, what we're worried about, and what NASA in particular is worried about for this rocket, is not just the winds on the top of the gantry of the rocket as we're looking at, but as it goes into orbit. So these balloons obviously can go tens of kilometers into orbit to actually test what is the winds above and below. But now the key here is the whole rocket is obviously going to a height of 350 kilometers. So in order to do that, they need to test up to as high as they possibly can to make sure it's stable enough for those winds. Now we still haven't had the rain, even though we still have winds or droplets on our screen here. Now, for those who asked, we cannot go near the rocket site. No one can go near it. That close where this camera is. It is closer even than people almost would want. So there's unfortunately no way of cleaning it. We will just deal with it as is. Some of the other shots are a little bit better. So we're still going to stay at it. We're still going to wait for the measurements for the weather balloon. This will give us the critical data that NASA needs to make those decisions, on the safety of the rocket, because it's not just the safety of the rocket, as we've been saying, it's a safety on the trajectory. So when this rocket, whenever it does, takes off, it's going to launch over, it's going to go over southwest Arnhem Land, so you have to be close in order to see it. If you are not in the vicinity, you won't see it. But look, you've been with us this long on the live stream. You're going to be with us to the end, and I appreciate it. We love you. I love you. Space loves us. And as long as the weather and the wind loves us back, we will see a rocket launch tonight. We still do have time in the launch window. Now, there is a limit to this launch window, but we're still in the time of it, so it's fine. We will just wait for those 10 minutes before we resume our T-3 countdown. Look, when we got to that T-8 seconds, oh, we were feeling like it was going to take off, weren't we? This room was electric. We're going to wait, though. So we will wait till we're there. We're still going to be with you. Now, one of the things that we've explored and one of the things that we really have seen with this is how do you build a spaceport in a remote part of Australia? And the history of Equatorial Launch Australia is an amazing one. The history of this vision to bring a rocket to here with a contract from NASA ready to go is an amazing story. You know, and I'm surrounded by people in this room who I know have been spending a lot of time on it doing various tasks. And look, they want to go as much as you, probably more than you, no offense, because they've been working for so long to see it, and they're waiting for it to happen. And we have people who have been standing outside in the rain just to wait it. There is passion, there is dedication from the entire team here, down the launch site, and all across it. And this is part of the ethos that has been part of Equatorial Launch Australia and this history to make it happen. And we're going to take a look at it real quick. We're going to take a look at that, of the story of ELA and how we've kind of gotten to today. Look, at this point, if people just want to chime in, sure, go ahead.
Hi, I'm Michael Jones, the Executive Chairman and Chief Executive of Equatorial Launch Australia. And tonight, we're doing Australia's first space launch from here in Arnhem Land. So watch this coverage and you will see the first commercial...
Sorry, we were playing the wrong clip real quick. We're going to load the right clip in a second. People are still waiting for the launch. We have people around the site getting ready to go. Again, it does appear that the rain has stopped. It is the wind, and as some people are noting, it is the wind at higher altitudes. The wind does increase as you get to those higher layers. And the wind, weather is variable. So even if you're in other parts of Arnhem Land or even Nhulunbuy, the weather may be very different from where we are inland, and that is always the key, is you need the weather at the site, at the readiness to do it. And look, we appreciate everyone's patience. We appreciate everyone staying with us. This is the first commercial launch in Australia. This is the first NASA launch from a commercial space point. And believe it or not, this is our first broadcast of a commercial space launch. Now, we have a dedicated, great team that is working with me who has been tired of listening to me, more almost than you, waiting for this launch to happen. But they are here. We are going to make it happen. And now we do have the clip ready to go of the history of ELA.
El primer lanzamiento llevará el calorímetro cuántico de rayos X, o XQC, de la Universidad de Wisconsin, Madison. XQC llevará detectores de rayos X únicos, enfriados a una gélida vigésima parte de 1 grado por encima del cero absoluto, para medir los rayos X interestelares con una precisión sin precedentes para comprender mejor el medio interestelar y su influencia en la estructura y evolución de las galaxias y estrellas.
And that's why we are where we are. And then in 2019, we were contracted by NASA, who expressed an interest in launching from the Southern Hemisphere, and specifically from Equatorial Launch Australia's site in Arnhem Land.
Equatorial Launch Australia and NASA go for launch right here in the Northern Territory. These rockets will go some 250 kilometres into the sky to collect data on the physics of the sun and its relationship with the Earth. It's about sending a message to younger Australians and indeed Australians of any age who might be looking at retraining for future careers of how important science is.
In the not too distant future, we will commence the operation of Phase 2, which will continue the development of the Arnhem Space Center to allow much larger and much higher frequency of operations.
And you know what? We're back on count. Yes! So, we are now T-minus 140 and counting. So, now as long as those winds stay away, we are going to see this rocket launch. Now, I'm sounding like a broken record, but this is okay. We are staying with it. We're going to get this launch. As of now, the winds seem to be as cooperating. And you know,
Agendar el próximo 12 de julio van a estar revelando las primeras imágenes asombrosas del James Webb Darien. Nuestro amigo de Explorando el Espacio va a estar en el CIO físicamente, en NASA Goddard, para contarnos.
We were going to stay in this count. We got to 8 seconds last time and then we had to wait.
Mañana lanzamiento a la Luna con Rocket Lab.
The 1 minute mark, we are still on track. Yep, so we are still counting down. We're getting close. We are getting close to Australia's first commercial rocket launch, NASA's first launch with an Australian customer anywhere. And I can tell when we're getting close because everyone abandons me right at the key time. That's when you know we're ready to go. But there are a few of us here to the bitter end, ready to go to see this. We're going to do it. We're at 30. 20. No. 7, 6, 5, 4, 3, 2, 1, go! Yeah! I need a camera. Where's my camera?
Way on the way.
20. No. 7, 6, 5, 4, 3, 2, 1, go! Yeah! That was awesome. 20. No. 7, 6, 5, 4, 3, 2, 1, go! Yeah! That was awesome. Go! Yeah! That was awesome. I need a camera. Where's my camera? 7, 6, 5, 4, 3, 2, 1, go! Yeah! That was awesome. I need a camera. Where's my camera? 4, 2, 1, go! Yeah! That was awesome. Taking that critical data. The telescope itself will only be operating for a few minutes, as we heard from Scott and others, as part of that launch. So it's a very short amount of time that they have. So as it's going, they will be getting the data, they will be getting the information they will need, and then hopefully it's a successful experiment. So the work hasn't stopped. I think that's the thing, is we saw the rocket take off. That's amazing. The work has not stopped. It is still going. We are still here. There are still people active on site, as you can see. The reason there are cars behind us, there are people still active in the mission, in the operation, the launch site and the command site. There are the science teams working on their data. Now, what will happen is, as the scientists collect their data, we have another group of scientists, and these are from Team 2 and the rest of the ELA employees who will be here for the third part, the second and third part of the launch. Now, as this data goes out, the scientists will be collecting their data. Now, this rocket will, and the payload will land kind of yonder, way beyond my shoulder, hundreds of kilometers behind. And tomorrow morning, it will be recovered. So, you know, the work hasn't stopped. The work has now just begun. That is the important thing about this launch. As the work happens, as we keep going, they will be collecting data. They will be getting their science. They have to collect the instrument tomorrow. Now, as we heard from Kevin, once you collect your instrument, you have to take it back to the lab. They're going to check it, make sure it works, make sure everything is kind of operating as planned before they say signed, sealed, delivered, and they can take it back to the U.S. Now, as we said, there are 2 more launches. So now we have just witnessed Australia's first commercial launch here from Yolngu country at the Arnhem Space Center. We have 2 more launches to go. Not tonight. There's enough excitement and buzz, and we've waited a long time. The second launch is scheduled for the 4th of July. That is the Sistine mission, an ultraviolet mission that will look at Alpha Centauri, the nearest star to us. We also then have a third mission launching on the 12th of July called Deuce, that will also look at Alpha Centauri, that nearest star to us besides the sun, but looking in the ultraviolet colors. So these are the very important missions looking at different types of the ultraviolet band, as we heard from Kevin, to measure the properties and composition of that star. So the X-ray team, based at the Launch Control Center down the road, is still getting their data. They still have minutes work of to do to collect it and come back down. Now, the recovery will not happen tonight. Obviously, we're in the middle of the night now. We've just ticked past midnight local time. Thank you to everyone who has stayed up through this endeavor. the helicopter crew and team will go out and recover the mission successfully, hopefully tomorrow, and that will all be handled safely. And this has already been coordinated with the traditional owners, the local landholders, and the emergency services. So any of you who were in the local region and just saw a rocket take off, boy, did you feel a kick, man. That was so powerful as it fell through. You saw the light and just heard the boom. It was, you feel it in your body. It was almost a way you can't even describe. And there just generally is an excitement, I think, by this team. As we've been hearing, there has been a work for years to make something like this happen, a huge amount of people to make something like this happen. And they've made it, they've seen it, they've been able to make it successful. And look, we have had a rocket launch takeover. We have had a rocket launch happen. And now, there's kind of almost a sigh of relief to some people. The rocket is done. In fact, NASA's job is done. NASA, once that rocket is launched, they are essentially said, hey, it is good to go. It is the science side. Obviously, there's a payload and recovery, and that is the critical part of Equatorial Launch Australia, is they are managing all of this, dealing with it, and seeing it. And look, we can watch this rocket vision time and time again. I mean, the fact that we just saw a rocket launch from beautiful Arnhem land, Yolun country, is an amazing thing. There are just, people are still standing outside, and there's nothing else to see. I think that's the beauty of it. So you were still seeing some of that rocket footage as you're seeing on the screen. And so, it really was that quick, powerful launch as we saw. We got the countdown. We got it. It was amazing to see. Look, I mean, as I said, there are people still standing, just almost kind of, not quite in awe, but I think appreciation, because there is a lot of hard work. There is a lot of science. There's a lot of engineering. And there's a huge team, as we see. I mean, there's quite literally a crowd of a couple of dozen people who have been working on site as part of this launch, who wanted to come out to see for those final few seconds for it all to happen. And I think this is a real sign. We now have clapping inside, so it does sound like the mission was a success from the science side. This is what likes to be counted as when the mission gets its critical data, the science is counted. NASA can say, we have had a successful launch from the Arnhem Space Center, held by Equatorial Launch Australia, the first commercial company to do so in Australia and to do so with NASA. It really is a momentous occasion. It is really great that everyone has been here to enjoy it. Thank you to everyone who's enjoyed us in the stream. We appreciate you lasting with us through this very long endeavor. We were worried about it ourselves. Was it going to happen? Was the wind going to stand away? It is wet everywhere we look, but it's kind of clear right above. It was clear enough. It was perfect enough. The winds were stable enough just for those critical final 3 minutes for the rocket to take off. That's exactly what we saw. That's exactly what you saw. And now we are done. We have reached this historical moment of the very first rocket launch from Australia. Thank you for tuning in. Thank you for staying with us. And we will be with you throughout the day tomorrow to cover what is the results of it. So keep up to date. We will be updating information as it comes to the public via YouTube, social media, and the media. Stay tuned for what is in store for now, the beginning of the journey. This isn't the end. This is the start.
No.